today, talking about using congruent triangles. We've talked about how to prove triangles congruent here. Side, 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 angle, 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 side, and hypotenuse, leg. Alright, these are all the ways to prove triangles congruent. So in this section, we're not necessarily learning anything new, but now we're looking at all these together and, okay, which one are we going to apply to the triangles we're talking about? And again, we want to reiterate this acronym here, CPCTC. Corresponding parts of congruent triangles are congruent. Alright, so we have these two triangles here. Explain how we can prove that angle A is congruent to angle C. Alright, so first off, we have to try and get triangles congruent in one of these manners. Alright, so the two triangles we're going to look at, I'm going to use triangle ABD as my original position triangle, which means I need to have one that looks like that. So I need a double arc there, single arc, and that's my corresponding position triangle. The vertex between the double and the single, that is C. Between the double and nothing, that's B. And then the last one is D. Alright, so I have my triangles in corresponding position. Now, can we get these two triangles to be congruent in one of these manners? Right now I have two pairs of sides congruent. So right away, I'm probably not going to use that one, probably not going to use that one, and we don't know we have a right angle, so I'm probably not using that one. So we're left with side, 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 and side, angle, side. Are we going to be able to get the included angle congruent or the third pair of sides congruent? Well, the included angle, that's angles A and C. Those are the ones we're trying to prove are congruent. So we're not going in that direction. We're going side, side, side. Alright, and then this question again, do we have any freebies? What do I mean by freebie? Well, just by the way this diagram is constructed, is there anything in these two triangles that are congruent because of the way the original diagram is constructed? Okay, and we see that the two triangles here, triangle ABD and triangle CBD, they are sharing segment BD. So we have segment BD is congruent to segment BD, right? And again, that is congruence is reflexive. That's one of those freebies. You don't have to do anything. You don't have to prove anything else. It's there because of the way the original diagram is drawn. Alright, that's a freebie. So now, are angles A and C corresponding parts? Yes, they are. They're in corresponding parts, or corresponding position, excuse me. They're in corresponding position, so yes, they are corresponding parts. Alright, so do we have congruent triangles? Yes, we have congruent triangles. Triangle ABD is congruent to triangle CBD because of side, side, side triangle congruence. Alright, the two givens and then the reflexive step. So the triangles are congruent. Then, if the triangles are congruent, we know that angle A is congruent to angle C because corresponding parts of congruent triangles are congruent. Okay? Next, we have these two triangles, or this diagram here, which are two triangles. Tell which triangles you can show are congruent in order to prove the statement. What postulate theorem would you use? We want to prove that angle D is congruent to angle C. So we have this original diagram. Alright, I'm going to draw actually both triangles, and this will be my original position triangle. So that's E, D, and A. Alright, which means I have to have a triangle that looks like that. Single, double, this is my corresponding position triangle. Alright, the point between the two is point A, so that's A over here. Point between the double and nothing, that's point B. And the point between the single and nothing is C. Alright, so I have my two triangles in corresponding position. Now, can I show these two angles congruent? Well, that would mean I need to get the triangles congruent. Alright, can we do that? Okay. Well, right now we have two pairs of sides. So if we look at how we prove triangles congruent, those are the two that deal with two pairs of sides. Are we going to be able to get these third pairs of sides congruent, or are we going to be able to get the included angle? Well, I take a look at my original diagram here. Is there any way we can get these sides congruent? I don't think so. Well, I look at my diagram here, and I look at these angles here. What kind of angle pair relationship does angle DAE and angle CAB have? Alright, they are vertical angles, right? And what do we know about vertical angles? They are congruent. So if vertical angles then they're congruent. So we know angle DAE is congruent to angle CAB. So what do we know about our two triangles now? We know our two triangles are congruent. We know that triangle DAE is congruent to triangle CAB. Alright, and that one is by side angle side triangle congruence. Okay? Then if the triangles are congruent, what does that tell you about all the remaining parts of our triangles? They are congruent. So angle D is congruent to angle C because of corresponding parts of congruent triangles are congruent. And again, this is one of those freebies. Just because of the way the original diagram is drawn, those angles are congruent. That angle pair relationship with vertical angles, they're congruent just because of the way the diagram's drawn. It's one of those freebies. It's there, you just got to know it. Alright, lastly, can we prove that angle VYX, this angle here, and angle WYZ, this angle here, can we prove those angles congruent? Alright, and we're given that angle T is congruent to angle U, segment XY is congruent to segment ZY, and that angle X is congruent to angle Z. We're given those three things. So I want to look at, we're talking about congruence here. We have congruent things, we're trying to get something congruent. I'm thinking we need to prove triangles congruent then. So I want to look at these two triangles. I have X, U, Y, and I'm going to use that as my original position, and I have that and that marked congruent, and this actually. So I want corresponding triangle. So I need a double arc there, I need a single arc, and I need a single slash. Now label my triangle. Well, the single arc is point Z, the double arc is point T, and the other point is Y. Well, what do we know about these two triangles right now with this given information? We know the triangles are congruent, right? Triangle UXY is congruent to triangle TZY. And that's by angle, side, triangle congruence. Now, because those triangles are congruent, what do we know about all the parts of the triangles? We know they're congruent as well, right? So, these angles here that we're trying to prove congruent are not parts of these triangles. But, I do notice, okay, angle UYX is congruent to angle what? Congruent to TYZ, right? Corresponding parts of congruent triangles are congruent. Alright? So, we know those two angles are congruent here. Now, if we look, angle UYX involves that angle here that we're trying to prove congruent, but it has a little extra here. As well as angle TYZ includes this angle we're trying to prove congruent, but it has a little extra here. What do we notice? Both triangles are using angle TYU. Alright, so we can say this. Angle TYU is congruent to angle TYU, right? Congruence is reflexive. Now think about this. This is where we're starting. We know these angles are congruent. This is where we need to get. How do we get from this point to that point? Knowing this is true. Alright, think about this. Angle UYX. Angle UYX is congruent TYU. This angle here. How do you go from something bigger, angle UYX, to something smaller? We need to get to TYX, here. How do you go from something bigger to something smaller? In math, we subtract. So if I take angle UYX and I subtract away angle TYU, am I left with angle VYX? Look at angle UYX. If I subtract away TYU here, am I left with this angle? Yes. If I take angle, TYZ, and I subtract away TYU, alright, angle TYZ, and I subtract away angle TYU, am I left with this angle? Yes. Alright, so here's step 7. How do we get from here down to here? If you take this angle minus that, we're left with this. Take this angle minus that one, we're left with this. What's the subtraction rule we know? Congruence minus congruence, the result is congruence. Okay? So that's the lesson for today. Please come to class with any questions you may have, and have a great day. Thanks.